Hello everyone. My name is Dr.E.Purushotham, Professor of Physics, Department of Basic Sciences, School of Sciences and Humanities. A warm welcome to today's video lecture. So today I am going to discuss about elements of vectors. So coming to elements of vectors. In these elements of vectors, you can see here the physical quantities are classified into two types. Number one is the scalar quantities. Number two is vector quantities. So, scalar quantity number one, a physical quantity which is having only magnitude but not having the direction. Only it has the magnitude. That type of physical quantity is called a scalar quantity. For example, mass, temperature, energy, and so on. So what about vector? A physical quantity which is having both magnitude and direction and also obeys the parallelogram law of vector addition. That is called a vector quantity. A physical quantity which is having both magnitude and direction and obeys the parallelogram law of vector addition. So that is called a vector. Examples, you see displacement. Displacement by time, it gives velocity. So velocity by time, acceleration, etc. A very important note here, for example, electric current is represented by I. So I have the magnitude and also direction, but not obeys the parallelogram law of vector addition. So electric current is a scalar quantity. Scalar quantity. So what I am saying, a physical quantity which is having magnitude but not having the direction, this type of physical quantity is called a scalar quantity. Examples, mass, temperature, energy, and so on. A physical quantity which is having magnitude and direction and also obeys the parallelogram law of vector addition is called a vector. Example, displacement, velocity, acceleration, and so on. Electric current electric current is having both magnitude and direction, but not obeys parallelogram law of vector addition. So it is not a vector. It is a scalar quantity. So examples of vectors and scalars. So you see here, this is the temperature, mass, time, distance. These are the scalar quantities. Velocity, force, volume, these are the, these are the vector quantities, vectors. Again, you can discuss here scalar and vector. The physical quantity which possess only magnitude but not direction in space, that is called a scalar. Mass, length, distance, time, etc. A physical quantity which is having magnitude, direction, and obeys the parallelogram law of vector addition, that is called a vector. So velocity, acceleration, field strength, and force, these are the vectors. So representation of vector, you can see here, this is the initial point or tail, this is the head point or end term. For example, this is initial point O, end point A. Simply we can show this is A bar or OA bar, A bar or OA bar. So you can see this is initial point, this is the end point, this is simply we can say A bar or OA bar. So the direction is A bar, magnitude is mod A bar, mod A bar. The symbol of or notation of vector A bar or A cap, we can show this is the unit vector, unit vector. So coming to position vector. What is the definition of position vector? A vector which is used to specify the particular position of any particular point or any object in a space. Space means three-dimensional x, y and z. So the vector which is used to specify the position of any point or object in space, that is called position vector. The position vector is denoted by r bar. It is denoted by r bar. So let us take here, this is x axis, this is y axis, perpendicular, this is z axis. From the origin at a distance of small r, let us take a point P in a space x, y and z. So along x axis unit vector I cap, y along y j cap, along z k cap. So here this is I, this is j, this is k. Then the position vector r bar is equal to xi plus yj plus zk. You can see here xi plus yj plus zk. So that magnitude is represented by r bar magnitude root of x square plus y square plus z square. Ijk are the unit vectors along x, y and z axis respectively. Or for example, if you want to take from the origin at a distance of unit vector head a bar, it is with the angle theta, then a bar is equal to, we can write axi plus ayj plus azk. What is this? A bar is equal to, we can write a bar is equal to axi plus ayj plus azk. Azk. That is the vector. So types of vectors. These are mainly 6 types or 7 types of vectors are there. So types of vectors, mainly these are divided into 7 types: null vector, proper vector, unit vector, equal vector, like vector, opposite vector and coincial vector. Coincial vector. So coming to first one, null vector. You see here null vector. A vector whose magnitude is equal to 0. So magnitude A is equal to magnitude of a vector is equal to 0. That is a null vector. If this magnitude is not equal to 0, that is proper vector. A vector whose magnitude is not equal to 0, that is a proper vector. For example, a magnitude of vector is equal to 1, unity. That vector is called unit vector. A vector whose magnitude is equal to unit or 1. Magnitude of A is equal to 1. That is unit vector. The unit vector is represented by A cap is equal to A bar by mod A bar. That is the unit vector. A vector whose magnitude is 0, magnitude of A is equal to 0, then the vector is called null vector. A vector whose magnitude is not equal to 0, then the vector is called proper vector. A vector whose magnitude is equal to unity, that is called unit vector. The unit vector is represented by a cap, that is equal to a bar by mod a bar. So coming to equal vectors, fourth one, equal vectors. So in the magnitude of a bar and direction of a bar, both are same, a bar and b bar. Two vectors are having the same values in magnitude and they are moving in the same direction. Vectors whose magnitude and direction is the same, this type of vectors are called equal vectors. Equal vectors. So like vectors, vectors whose magnitude is not equal but they are moving in the same direction, that is called like vectors. So vectors whose magnitude is not equal but the direction is the same, this type of vectors are called like vectors. So you see, the vector a and b are moving in the same direction but the magnitude is different. Direction a is equal to b, you can see that magnitude mod a bar is not equal to mod b bar. Next, sixth one, opposite vectors. Vectors whose magnitude is equal and direction is not same. The direction is not same. So magnitude of a bar is equal to magnitude of b bar, but a bar is equal to opposite minus of b bar. So coincial vector, you can see here, this vector is the coincial vector. Vectors which have originated from same point, that vectors are called coincial vector. So you see, the vector A is moving from the origin. The vector B is also moving from the origin. The C is also moving from the origin. D is also moving from the origin. Vectors which have originated from same point, the all A, B, C, D are moving from the origin O. This type of vectors are called coincial vectors. Coming to resolution of vectors. So you try to see clearly this figure. So on x-axis, this is y-axis. Try to see, this is x-axis, this is y-axis. So OA is vector and making OA, you see, OA is a vector. It is making an angle theta. Direction of vector, that is theta, which horizontal AB and AC are normal to x-axis and y-axis respectively. So from the figure, you try to see OB is equal to AC is equal to horizontal component AX. AX, that is X component. You see here, X component. And another one, OC is equal to AB is equal to AY. That is Y component or vertical component. Y component or vertical component. From the triangle, you try to see here, from the triangle OAB. So I want to take cos theta. Cos theta is equal to adjacent side OB by hypotenuse OA. Adjacent side OB, that is AX bar, hypotenuse mod A bar. So you see here OB by OA. From this relation, AX is equal to mod A bar cos theta. Mod A bar cos theta. Let that is equation number 1. From the same triangle, I want to take sine theta from the same triangle OAB. Sine theta is equal to opposite side AB by, this is the opposite side by hypotenuse OA. So AB, that is AY, OA, that is mod A bar. You can see this is from this relation AY is equal to mod A bar sine theta, that is equation number 2. Equation number 2. From the equations 1 and 2, that is equation 1 square plus 2 square. So equations 1 square plus 2 square. What happened? So left side ax whole square plus mod ay whole square is equal to right side mod a square cos square theta plus mod a square sin square theta. So right side mod a square common, in bracket cos square theta plus sin square theta. So here also we can see cos square theta plus sin square theta, that is 1. So this is remaining mod a square is equal to ax square plus ay square. So mod a bar is equal to root of ax square plus ay square. This is the magnitude of vector A. So simply the horizontal component ax is equal to a cos theta, vertical component ay is equal to mod a sin theta, mod a sin theta. So the magnitude mod a is equal to root of a square plus ax square plus ay square. So direction, you try to see here equation 2 by equation 1. So equation 2 mod a bar cos theta, that is mod ay, that is equation 2, divided by equation 1 mod a bar by, so equation 2 that is ay is equal to mod a sin theta, this is equation 2, ay is equal to mod a bar into cos theta, this is equation 1. So equation 2 by 1, this is equation 2 by 1, this is mod a bar gets cancelled, ay by, this is ax, ay by ax, this is mod of, is equal to sin theta by cos theta, that is tan theta. So you can see here, this is equation number 2, this is equation 1. Mod a sin theta by mod a cos theta is equal to ay by ax. So this is ay gets cancelled. This is sin theta by cos theta tan theta is equal to ay by ax. Ay is the y component, ax is the x component. So tan theta is equal to y component by x component, or simply theta is equal to tan inverse of ay by ax. So on this theta, we will do one problem, simple problem. What is the angle made by vector of A 2i plus 2j with x-axis? So we can take here given vector A bar is equal to 2i plus 2j. So A bar is equal to, in general, axi plus ayj. At the place of ax, Ax is equal to 2 at the place of Ay is equal to 2. So theta is equal to tan inverse of Ay by Ax, 2 by 2. So theta is equal to tan inverse of 1, theta is equal to 45 degrees. Theta is equal to 45 degrees. Coming to next topic, vector addition. Addition of two vectors. So addition of two vectors can be divided into two ways. Number one is triangle of vector addition and number two is parallelogram law of vector addition. So triangle of vector addition. If two vectors are represented, for example, take this is A bar, this is B bar. These two vectors A bar and B bar. If two vectors are represented in direction and magnitude by sides of a triangle taken in order, then the resultant vector is represented in and magnitude by third side of the triangle taken in reverse order. So this is the reverse order. So this A bar and B bar same order, this R bar reverse order. R bar is equal to A bar plus B bar. This is the triangle law of vector addition. If two vectors are represented in direction and magnitude by sides of triangle taken in order, then the resultant vector is represented in direction and magnitude by third side of triangle taken in reverse order as shown in this figure. So try to understand here, if resultant is also taken in reverse order, that is vector addition. If the resultant is taken in the same direction, that is the subtraction, vector subtraction. So triangle of vector addition. So this A bar and B bar, A bar and B bar are taken in the same direction. The third side taken in reverse, the resultant C bar is equal to A bar plus B bar. If the resultant is taken in reverse order, that is the triangle of vector addition. If the resultant is taken in the same direction, so OA bar, this is AB bar, this is OC bar or BO bar. So this is resultant is taken in the same direction. C bar is equal to A bar plus of minus B bar. So simply C bar is equal to A bar minus B bar. This is the subtraction. So coming to parallelogram law of vector addition. If two vectors are represented, so two vectors A bar and B bar. If two vectors are represented in direction and magnitude by two adjacent sides of the parallelogram, the resultant vector R bar is represented in direction and magnitude by diagonal of the parallelogram formed by two vectors. So try to understand here, theta is the angle between two vectors A bar and B bar. Alpha is the direction of resultant or the angle between A bar and R bar. Then the resultant vectors A bar and B bar is the resultant vector R is equal to root of A square plus B square plus 2AB cos theta. The direction of resultant vector alpha is equal to tan inverse of y component by x component. That is the tan inverse of y component CD by OD. So CD as it is, tan inverse as it is, CD as it is, but OD you see from this point to this D point, we can write this is OA plus AD. OA plus AD. You can see here AD. Here to here OA plus AD. So you see here. But CD, this is the B sine theta by OA, this is A bar. OA, this is B, OA. Before that OA is the A bar, you can see here, and AD B cos theta. So alpha is equal to tan inverse of B sine theta by B cos theta plus A, or this is B sine theta by tan inverse of B sine theta by A plus B cos theta. A plus B cos theta. This is the direction, resultant vector direction. So addition of vectors given A bar, this is B bar. So A plus B, we can write AXI and AYJ as it is. I am taking this A bar up to here, A bar I am taking as it is, remaining this is B bar. So take the common and write AX plus BX, I plus J common, AY plus BY plus K common, that is remaining AZ plus BZ. This is valid only if two vectors are in same direction, that is theta is equal to 0 degrees. If two vectors are in opposite direction, theta is equal to 180 degrees, then A bar minus B bar is equal to AX minus BXI plus AY minus BYJ plus AZ minus BZK. If two vectors are in random direction, 0 less than theta, theta less than 180 degrees. Coming to multiplication of vectors. The multiplication of vector by a scalar. The multiplication of a vector by scalar or a pure number, say n, give a vector in the same direction but n times in magnitude. A bar is equal to n times the A bar. Multiplication of vectors are two types. Product of vectors can be either scalar or vector, depends on the type of multiplication. So the product of two vectors are two types, dot product and cross product. So clearly try to understand here product of two vectors. Product of two vectors can be divided into two types. Number one is dot product, or it is also known as scalar product. Second one, cross product, or it is also known as vector product. So dot product, you see here, this is the dot product. Why it is called scalar product of two vectors? So the resultant of dot product of two vectors is a scalar. For example, work done is equal to the vector force dot displacement vector S. The dot product of this force and displacement gives a scalar quantity. So it is also known as a scalar product. The two vectors dot product gives a scalar, so it is called scalar product. Resultant of dot product of two vectors is a scalar. So definition, you try to give his definition. A bar dot B bar is equal to magnitude of A bar, magnitude of B bar and cos theta. The product of magnitude of two vectors and the cosine angle between them is called dot product. The product of magnitude of two vectors and the cosine angle between them is called dot product. So given two vectors A bar comma B bar, The dot product A bar dot B bar is equal to mod A mod B cos theta. Theta is the angle between A bar and B bar. What is the significance of the dot product? So overlap of second vector on the first vector. So try to understand here. A bar dot B bar is equal to mod A mod B cos theta. So we can write here A bar of B bar cos theta. Cos theta. So we are taking here, this is OA. The OA, the resultant vector B bar or another vector B bar, the angle between A bar and B bar, that is theta. So horizontal component we can take mod of B cos theta. Mod of B cos theta. This is mod of B cos theta. This is the first vector. This is the second vector. The second vector is overlapping on the first vector is the significance of dot product. So overlap of second vector on the first vector is represented by A dot B, that is equal to mod A of B cos theta. So coming to examples. Work done W is equal to the vector F bar dot S bar. So this work done is a scalar. Power P is equal to work done per second. So work done is equal to F into S by this is T. Displacement by time, it gives the velocity. These two vectors dot products give the scalar quantity of power. P is equal to F bar dot V bar. Potential energy. Potential energy is represented by the force into that height, that displacement, force into displacement. So F is the mg, g is the vector, dot h is the vector. So mg dot h. These are the examples of dot product. So dot product of unit vector. So I dot I. So unit vector mod I cos. So I vector with I vector, the angle is 0 degrees. Mod I 1 unit vector 1, mod I unit vector 1, cos 0 1. So I dot I is equal to 1. Similarly, j dot j is equal to 1, mod j cos 0. K dot k is equal to 1, mod k cos 0. So we can write I dot I, j dot j is equal to k dot k is equal to 1. So another one, I dot j, this is mod I, mod j. In between x-axis and y-axis, 90 degrees. Or between I and j, 90 degrees. So this is cos 90 degrees. Cos 90 0. So we get I dot j is equal to j dot k is equal to k dot I is equal to 0. 0. Here taking two vectors. A bar is equal to AXI plus AYJ plus AZK. B bar is equal to BXI plus BYJ plus BZK. You can see here, this is A and this is B. But A dot B, A dot B is equal to, simply you remember AXBX plus AYBY plus AZBZ. You see here, for example, AXI multiplying dot product with BXI. So I am taking here AXI dot BXI. It is equal to AX into BX I dot I dot I, what is the value? So this is 1. So we get ax bx, ax bx. Coming to this axi with this byj dot byj. What happened? It is equal to ax by into I dot j. So I dot j, that is 0. 0 into something 0. So remaining this axi dot j 0. Axi dot this bzk is also 0. 0. So coming to next term. So this first term completed. Coming to next term, ayj. Ayj into bxi, j dot I 0. Ayj byj, ay by j dot j. So we get second term. And another one, this ayj dot product of bzk. So ay bz j dot k is 0. So similarly, we can check remaining also. A dot b is equal to ax bx plus ay bz, ax bx plus ay by plus az bz. That is the a dot b formula. So again, you know very well here, a bar dot b bar is equal to mod a mod b cos theta. From this relation, cos theta is equal to a bar dot b bar by mod a mod b. So cos theta is equal to, we can write the formula, a dot b is equal to ax bx plus ay by plus az bz by root of mod a bar, that is ax square plus ay square plus az square into mod b bar, root of bx square plus by square plus bz square. This is the angle between two vectors. So dot product of two vectors, that I dot I is equal to j dot j is equal to k dot k is equal to 1. I dot j is equal to j dot k is equal to k dot I is equal to 0. So dot product of two vectors, a dot b is equal to ax bx plus ay by plus az bz. Angle between two vectors in dot product, cos theta is equal to a dot b by mod a mod b. Mod a mod b. So coming to second one, cross product or vector product. The cross product or vector product resultant is a vector quantity. For example, the velocity is equal to position vector cross product of angular velocity. So r bar is vector and omega bar is vector. The cross product of two vectors gives the another vector. So it is called vector product. The resultant is a vector quantity. You can see here. So here this is vector a bar. This is vector b bar on the plane of a bar cross b bar. So this plane we can represent a bar cross b bar. It gives the resultant. R bar is equal to a bar cross b bar. That is mod a mod b sin theta n cap. The resultant of vector product is a vector and the direction of the resultant vector is perpendicular to the plane formed by vectors. So what is the definition? You see here, a bar cross b bar is equal to mod a mod b sin theta n cap. Here also n cap. The magnitude of cross product of two vectors is product magnitude of two vectors and sine angle between them. The product of magnitude of two vectors and the sine angle between them is called cross product or vector product. So A bar cross B bar is equal to mod A mod B sin theta n cap. What is the significance of this cross product? The significance is the resultant of this cross product again gives a vector, that is the significance. What are the examples of what are the examples of cross product or vector product? So first one, linear velocity, it is represented by v bar. Position vector r bar, angular velocity omega bar. So linear velocity v bar is equal to r bar cross omega bar. Angular momentum L bar is equal to the position vector r bar cross linear momentum p bar. L bar is equal to r bar cross p bar. So torque tau is equal to position vector r bar cross force F bar. Tau bar is equal to r bar cross F bar. So these are the cross product examples by using the right hand screw. The direction of resultant vector obtained by cross product of two vectors is given by the right hand screw rule. So for example, the index finger showing vector A and the middle finger shows the vector B, the thumb gives the resultant vector. So in figure A, the resultant vector r bar is equal to a bar cross b bar. In figure B, also same in different. So r bar is equal to a bar cross b bar. Here also vector representation of torque using cross product. So we can change, this is torque, the moving. So rotating along the position vector, some applying force, that is torque tau is equal to the position vector r bar cross f bar. So you can see here effective torque first one, ineffective torque second one. So cross product of two vectors. You see generally I cross I. So mod I sin 0. Sin 0 is 0. So I cross I is equal to 0. Similarly j cross j is equal to 0. And also k cross k is equal to 0. So in second one, for example, I cross j is the clockwise direction. So I cross j gives the k. J cross k gives the I clockwise direction. So you see here in clockwise direction take the positive third vector and anti-clockwise direction take the third vector as negative. So I cross j gives in clockwise k, j cross k gives the I, k cross I gives the j. In anti-clockwise direction, I cross j, that is minus j, j cross I minus k cross j minus I. You can see in these two figures. Cross product of two vectors. So a bar is equal to axi plus ayj plus azk. B bar is equal to bxi plus byj plus bzk. So take a bar cross b bar is equal to magnitude of I, j, k. Take the A vector related ax, ay, az. Next b vector bx, by, bz. So you can see here. So this resultant to take first I minus j. So this is minus j. Take it. So here this resultant is equal to, this is minus j plus k. You take here, for example, you want to take here a cross b. First, this is for I related, just horizontal and vertical, you close it. Remaining AYBZ minus AZBY. So I completed. Coming to J, for J also close this horizontal and vertical. Remaining AXBZ. AXBZ, you can see. And AZBX. AZBX. So J term also completed. Now coming to K, also horizontal close and also vertical. Now AXBY minus remaining AYBXK. So like this we can calculate the cross product of two vectors. So you know very well sine theta A bar cross B bar is equal to mod A mod B sine theta. From this relation, we can calculate the angle sine theta, angle between two vectors, sine theta is equal to A cross B or mod of A cross B by mod A mod B. So like this, we can understand the cross product of two vectors. Summary of today's lecture. The vectors are physical quantities which are having both magnitude and direction, unlike scalar which have only magnitude. So only a physical quantity which is having only magnitude but not direction, that is a scalar. But a physical quantity which is having magnitude, direction and also obeys the parallelogram law of vector addition, that is vector. So we discussed in this video. Common vector operations include addition, subtraction, multiplication, dot product and cross product we discussed clearly. The product of and magnitude of two vectors and the cosine angle between them is called dot product. The product and magnitude of two vectors and the sine angle between them is called cross product. Vectors are used in physics to describe motion, displacement, force and fields. In especially computer science, vectors are applied in graphic, artificial intelligence, machine learning, and game development for movement, data representation, and spatial calculations. Also, we will use these vectors. Understanding the vector concepts builds a strong foundation for analyzing physical systems and implementing real world simulations in computing. Thank you all. Thank you. Thank you so much.